So we have finally calculated the range of the vehicle, and if you see, we consider this driving cycle which has a multiple event. It associated with event which has an acceleration mode, it has a deceleration mode, and sometimes it is going at the constant speed. But my question or my curiosity is it possible to summarize this entire drive cycle with one event? And when I say one event, I am talking about when the vehicle is going at the constant speed. What is that constant speed or the average speed I'm talking about? So I'm talking about the average speed that I calculate from this drive cycle. So in order to calculate average speed, just I have to do what? I have to divide total distance traveled divided by the total time it took. So then I got it 22.4 kmph. So what would be the driving condition so that my vehicle should travel with 22.4 kmph, but it can consume the same amount of energy that has consumed in this driving pattern? And when I say the same amount of energy is with 0% regenerative. Why? Because I am now driving my vehicle with the constant speed, and hence there is no regeneration in that because I am not decelerating my vehicle. So I have to consider the energy consumption at a 0% regeneration. So that's what I have calculated the energy at 0% regenerative, which I got it how much? 115.32 watt hour per kilometer. So now what is the driving condition that I need to find out so that vehicle can travel with the speed of 22.4 kmph and still it is consuming 115.32 watt hour per kilometer. So to calculate the driving condition, let's come to this vehicle dynamics sheet. So first I am going to get this watt hour per kilometer right, because I know that this value is only and only depends upon the torque of the motor. So let's get the help of our goal seek friend and then set this value 115.32 while changing the torque of the motor. So I got the torque value right, but the speed of the vehicle is now 64.4 kmph. But how much I need? I need 22.4. How do I get it? I cannot change this torque, because if I change this torque, my watt hour per kilometer is going to change. The only input I'm left with to change the slope of the road. So now in order to set the average velocity, which is equal to 22.4 kmph, by changing the slope of the road. Great. So let's say if I am driving my vehicle with 22.4 kmph on the road which is having inclination of 0.72 degree, then I am going to consume same amount of energy that I calculated in my driving cycle, which is 115.32 watt hour per kilometer at 0% regenerative. So here this is the vehicle operating point, or it is a single event which summarizes the entire drive cycle. What is that single event? When the vehicle is going with the speed of 22.4 kmph on the road which has inclination of 0.72 degree. But what is the use of it? What is the advantage that I see while calculating this thing? And let me tell you, it is having the biggest advantage. With this, we can find the operating point of the motor, or torque and RPM pair of the motor. So we already got the torque of the motor, which is how much? 10.72 which I have written here. And then what is the RPM of the motor at this speed? We got it here, 2300. So that's what I have written. This is the precious pair because this is where my average efficiency of the motor is going to be. And let's say I am getting the motor from the outside, and then I will ask the motor manufacturer what is the efficiency at this point, because in my driving cycle this point is going to represent the average efficiency of the motor. And let's say motor manufacturers say it is just 80%, but I have considered here 85%, which means that the motor is not good. And then I will ask manufacturer, can you improve your motor in order to get the higher efficiency, which is 85%. So this number is now becoming for me to evaluate the motor whether it is bad or good. So this is the biggest advantage for me. If I know this operating point, I can ask motor manufacturer what is the efficiency at this point, and that efficiency is valid for me in overall driving pattern. So I hope that you got all the idea about the driving cycle. And finally, we have completed all the discussions. So now you can calculate the range and the what I call vehicle operating point and the motor operating point with your own driving cycle. You are free to add all this another event, and then you can calculate it. But you don't have to do this much manual work. I have already designed this Excel sheet in automation mode, so which I'm going to discuss later. But to just give you a gist of it, you have to just come in this. You have to put your drive cycle data here, and then motor plus controller efficiency, depth of the discharge, regenerative, and battery capacity. You just have to hit the calculate button, and then you will get a result in this dashboard. So this is where you get the drive cycle summary, the vehicle speed, the road gradient, the motor torque, and the motor RPM. And this here you will get the idea of the range. But this I'm going to discuss in detail how to operate this in an automation mode. So this is all about drive cycle discussions. Let's go to the next set of discussion.